Okay, today's lesson is about multiplying and dividing rational expressions. The steps are very similar to simplifying, with one extra at the end. The first step is to factor the numerator and the denominator. It's going to be the same for dividing. It's going to be the same for adding and subtracting. The second step is to divide out the common factors. Now that we're multiplying and we have more than one fraction, we can divide out diagonally and we can divide out vertically. Horizontal is multiplication. Division is diagonally or vertically. So we can divide anything common out, and then the last thing will be to multiply horizontally the factors that are remaining. And if it can be simplified more, we will do that. So the first one, we're just going to do the one on the left side, and then you can try the next problem. So we have 6x squared y divided by 3xy cubed times 9x to the fifth y squared divided by 2y. We're going to, this is one of those lots of variable type problems where I don't really have any factoring to do. So there's a couple ways we can do this. We can divide numbers out and then deal with what's left. We could multiply it all together first, because this is more of a monomial type problem that we did back in chapter 5. But we're going to kind of look at this a little bit differently this time around. So the first thing I want to do is look for the numbers. When I see these numbers, I see that 3 goes into 6 2 times, and 2, this 2 can be divided by that 2, because I end up with 6 times 9 over 3 times 2, which is 6. So the 6 basically cancels. And so this 2 cancels this 2. So I'm left with the only number on the top, which is going to be 9, and the denominator is going to have a 1. And overall, I have x squared over x, and then I have x to the fifth. So this 1x here can cancel one of these x's. And x to the first times x to the fifth can give me x to the sixth power. And this y, let me do this in a different color, this y can cancel one of these y's. And this y cancels one of these y's and leaves 2. So now we have, what do we have left? We have a y on top and a y squared on the bottom. And that 1y cancels this and leaves 1y on the bottom. So my final answer would be 9x to the sixth over y. And we could look at that a little bit differently if you'd like. You can see that if I multiply the top together, I have y cubed on top, and y cubed times y is y to the fourth on the bottom. I end up with the same thing, 1 over y. The y stays in the denominator. And if I look at the x's that way, I would say x to the seventh on top, and then I'd see 1x on the bottom, which would give us x to the sixth over 1. So that's why it's in the numerator. So there's several different ways to look at this one type of problem. Domain-wise, we look at the same thing, our original problem, all of our denominators. We have x's and y's, x and y, such that x cannot equal 0, and y also cannot equal 0. And that would be our domain, all the numbers, such that these two things have to be true as well. So if you'd like to give this one a try, go ahead and try this problem on your own. Pause the video, do the problem, come back and see if you got the same answer. Pause it now. Okay, we're going to do, I'll do it real quick. 3 goes into 9 3 times, and 8 divided by 2 is 4, 6 divided by 2 is 3, and the 3's cancel. The only thing I'm left with here is a 4 in the denominator. If I look at the top, x to the fifth times x is x to the sixth over x to the fourth, which gives me x squared on top. I definitely like that method better. And then y to the fourth over y squared, I get y squared in the numerator, and that covers all my bases. Even though there's no variables in the bottom of my answer, my domain is still that x and y cannot equal 0. Let's look at the next problem. So this is one where we're going to definitely need to factor, so we're going to factor out the numerator, the denominator, and the numerator. So all three of those have to get factored. So the common factor of this numerator is 5x, and then I get 1 minus x squared, 1 minus x. And then the denominator, two numbers that multiply to positive 3 and add to negative 4, is x minus 3 and x minus 1. And then the two numbers that multiply to 6 and add to negative 5 is x minus 3 and x minus 2. And then we have the 5x. I meant to do this. Let me write that. So first glance, what do I see that I can cancel out? I got the 5x divides the 5x. Remember, I can go diagonally or vertically. I have this x minus 3 divides with this x minus 3 to give me 1. And what did we say again when we had 1 minus x and x minus 1? Well, yesterday we talked about that in the simplifying video, that when we have opposites like that, they divide out and equal a negative 1. So these divide, but they leave a negative 1 behind. So we get, only thing left is the negative 1 and the x minus 2. So it's negative x minus 2 is our final answer. And then what domain? We look at the domain and we see x cannot equal from this parentheses 3, from this parentheses 1, and from 5x, x cannot equal 0. So x does not equal 0, 1, and 3 is our domain. Okay. Now go ahead and give this next problem a try. Pause it, do it, unpause it when you're done. So you should be paused right now. All right. Now let me see if you got it right. Let's factor out the top. 2x times x minus 5 over x plus 5 times x plus 5 times x plus 3 over 2x squared. So what do we see that we can cancel out here, divide out? The, oh, I did something wrong. This needs to be a minus. There we go. And what divides out? X minus 5 divides out. The 2 divides out, and one of the x's divides out. So what I'm left with on the numerator is x plus 3. And in the denominator, I'm left with this little x over here times the x plus 5. And I don't need to multiply it back out. I can leave it in factored form. And then for the domain, we look at the problem before it was simplified. So before we divided anything out, we know that x cannot equal, from this one, x cannot equal 0. From this one, x cannot equal 5. And from this one, x cannot equal negative 5. So x does not equal negative 5, 0, and 5. You don't get marked off if you don't write it in numerical order. And I just don't have space for my curly brace. There we go. Okay. And let's look at a couple more. What if we're multiplying by one that's not a fraction? Well, the same rule applies if it were just fractions. We just put it over 1. So we're going to put it over 1, and this is a numerator. So I have x minus 7, and x cubed plus 8. We need to recognize that. That's a sum of cubes. So it's going to factor to x plus 2, right? Because your a is 2, and I'm sorry, your a is x and your b is 2, and it's a plus b, a squared, so x squared, minus ab, minus 2 times x, plus b squared, which is 4, times by the x squared minus 2x plus 4, not factorable because there are not two numbers that multiply to 4 and add to negative 2. And we'll simplify out this the x squared minus 2x plus 4 cancels, and I'm left with x minus 7 over x plus 2. And we can look at the domain. This is the x plus 2, x such that x does not equal a negative 2. The x squared minus 2x plus 4 gives an imaginary answers. And we're working in the real number system now, so we don't need to list imaginary answers as domain restrictions. Okay, and have you do this one. Pause it, do the problem, unpause it. Okay, here we go. I get x plus 2, x cubed minus 27, x minus 3, x squared plus 3x plus 9. That's my difference of cubes pattern that we talked about the other day, times the x squared plus 3x plus 9, which cancels, so we get x plus 2 over x minus 3. And your domain is not bothered by the x squared plus 3x plus 9 because those are imaginary, so x does not equal 3. And that is your multiplying. Okay, now we're going to divide, and the first step to division of fractions is to flip the second fraction and change it from division to multiplication. So then we'll do all the steps for multiplying, because we're just going to multiply after that. So step 1, flip my second fraction, so I have 11x over, can I factor that at the same time? 3 times x minus 3 times x squared minus 8x plus 15 over x squared minus 5x. So I flipped it to multiplication, and I do the reciprocal of the second fraction only. And now I'm going to factor the other side, 11x over 3 times x minus 3 times x minus 3 and x minus 5 are the two numbers that multiply to positive 15 and add to negative 8. And then x squared minus 5x, the only thing I can do is take out the x times x minus 5. And now we're going to divide out any common factors we have. I see an x minus 3 as a common factor. I see an x as a common factor. And I see an x minus 5 as a common factor. So the only thing left is 11/3. But my domain is based on the original problem. And because I'm dividing by this second fraction, none of that fraction can equal 0. Not the numerator or the denominator, because I'm dividing, and I can't divide by 0. So I have to look at all of this here, highlighted in blue, when I'm looking at the domain. The entire second fraction and the denominator of the first fraction. When it's a division problem, all of that gives us our domain. So we say that x cannot equal, let's see, from here, positive 3. From here, 0. From here, 5. From here would be positive 5. I don't have to list it twice. And from here, positive 3. So there's my domain. I have to look at all of the second fraction in order to determine which number this cannot be. Okay, here's one for you to do. Pause it. Do the problem. At this point, you should have done the problem. You're going to unpause it and see how you did. So I'm going to flip the second fraction, x squared minus 6x plus 8 over x squared minus 2x divided by 4x over 5x minus 20. And let's see, we get 4x. I can factor out a 5, so 5 times x minus 4. Change it to times. Sorry, I made that mistake up there. Factor x minus 4, x minus 2. Those are two numbers that multiply to positive 8 and add to negative 6. Factor out the x out of x squared minus 2x. We get x minus 2. And now what can we divide out? The x minus 4 divides out. The x minus 2 divides out. The x divides out, and I'm left with 4/5. That's my final answer, but what was my domain restrictions? X cannot equal, let's see, net positive 4, 0, 2, 2, and 4. I don't have to relist anything twice. So 0, 2, and 4 are my domain restrictions, the values that x cannot equal. All right. One more example and one more for you to try. Factoring. Oh, this one has a coefficient, so let's talk about how to factor that after we flip it. Now, if we're dividing by just a polynomial, it's not a fraction already, what do? We put it over a 1, and then we flip it. So we have 6x squared plus 4x minus 2 over 5x squared times 1 over 2x squared plus 2x. Now we can factor. Let's see. I see a common factor here, so I'm going to make this factoring a little bit easier by taking a 2 out. 2 times 3x squared plus 2x minus 1 over 5x squared. And that's 1 over 2x times x plus 1. And then let's factor what's inside that parentheses. 3x and x. That's the only way to get 3x squared. And the only way to get this 1 is 1 and 1. So the question is, where does the negative sign go so that I get a negative 1 and a positive 2? Remember, I'm checking my outside and my inside. My outside is 3x, my inside is 1x. I need it to be a positive 2, so the 3 has to be positive, the 1 has to be negative. That makes it minus here and plus here. So 3x minus 1 and x plus 1. So now I'm going to erase that work so I can add the bottom of my fraction in here. And that's all over 5x squared and 1 over 2x times x plus 1. So what can I divide out now? I can divide out the 2. I can divide out the x plus 1. And that's it. So my final answer is the 3x minus 1 times 1. 3x minus 1 on top. And then the 5x squared times what's left over here is the x. So 5x cubed. And then I have to look at this whole fraction. What can x not equal? X cannot equal negative 1, 0 for this x, and 0 for this x. So x cannot equal negative 1 and 0. I don't have to worry about the 1 on top because there's no variable. That's my final answer. All right, last problem, guys. Pause it, do it. Okay, you've done it. Let's see if you did it right. How do I factor 2x squared? This is going to become 1 over 2x squared plus 5x, and that's going to become times. And so let's see, 2x and x is the only way to get your 2x squared. 5 times 1 is the only way to get your 5. So I want 3x, so I'm going to put the 5 here and the 1 there. That gives me 2x and 5x. If I want a negative 5 but a positive 3, I need the 5 to be positive, so a plus in the 2x plus 5, and the 1 to be negative, so it becomes x minus 1. And then the denominator is your 6x times 1 over, I can factor out an x, times 2x plus 5. Now, sometimes we might want to look at our domain first. X cannot equal 0. That's from the 6x here. X cannot equal 0 from this as well. There's no variable on top. And 2x plus 5, I have to set that not equal to 0. If I subtract the 5 and divide by the 2, I get negative 5 halves. Right, so that's 2x plus 5 cannot equal 0, and you can solve that. Now what divides out? My 2x plus 5 divides out. And that's it. I have x minus 1 times 1, x minus 1 in the numerator, and 6x times x is 6x squared. That's my final answer, and there's my domain. And that is dividing rational expressions.